Hello guys, welcome back. Today I'm going to be going over product and quotient rule, and this is for basically anyone who wants to do maths or who's doing A-level maths, further maths, maybe IB. Anything you want to know, I'm going to teach throughout these videos. So let's get started. I like to get started straight with an example without actually explaining the rule itself because I find it easier to follow a set format. So pretend we have y is equal to 5x sine x, and you want to differentiate it. The reason why we can't differentiate this normally is because we've got two things that contain x. Okay, so when to use product and quotient rule, okay, and this rule will always work and always help you. It's when you are multiplying two expressions with x in them. Okay, so it doesn't have to be distinct. So you can have, for example, you can have y equals sine x. Okay, you can, that is a valid example. You can use this product rule. You can use something such as I said, the first one. You can have something such as, it doesn't have to even be sine x. You can put 5x e to the x, or y equals e to the x 10x. It doesn't matter about order. You can do it with any expression which has multiple expressions. Okay, so let's get started with the first example. So my first example is going to be y equals 5x sine x. So this is a good format I want to do. So first of all, you want to separate these two. So you can say u is equal to 5x, and you can say v is equal to sine x. Okay, now you want to differentiate both of them. So du by dx is equal to 5, dv by dx is equal to cos x. And then what you want to do, you want to draw two arrows like so, and then add them together. So I can say dy by dx will equal 5x cos x plus 5 sine x. Okay, and that is my final answer. Let's go through another example. Let's go through y equals sine x sine x, which is equal to sine x squared, or you can say that's equivalent to, people write it like this. Okay, so let's differentiate this. So let's use the same format again. I would like you guys to have a try first, but let's go with the same format. So u equals sine x, v equals sine x, du by dx is cos x, okay, and dv by dx equals cos x. And then again use a rule like so. So dy by dx will be equal to sine x cos x. Okay, so I'm multiplying this by this plus this by this, okay, plus sine x cos x, which is equal to 2 sine x cos x. Okay, there we go. My final answer is there. Let's go through one more using e to the x. So let's say y equals 10x e to the x. Okay, so we can say u equals 10x, f equals e to the x. We can say f, we can say v, it doesn't really matter. This is why I used f for this example, is equal to 10. Okay, let's just put v for simplicity reasons. dv by dx is e to the x. And then again, draw the two arrows, and we can say dy by dx is equal to 10x e to the x plus 10 e to the x. Okay, and that's my final answer. So that is what we call the product rule. Why is it called product rule? It's because you're multiplying. Okay, and you can get that rule and that familiarization because you said product rule. Let's go through quotient rule. Quotient rule is very similar. Okay, but quotient rule relies on the fact that it is a quotient, so something like dividing, right? So let's go through an example. So pretend you have something like 5x over e to the x, right? How will you differentiate this? Well, you could say I can use a product rule and say, okay, 5x e to the x is the same as 5x e to the minus x, and use a product rule on this, right? You can use product rule on this. But let's just say we want to just keep it on this and not do e to the minus x. All right, we want to just use a quotient rule on here. Okay, so what we do, we say u is equal to 5x, and we say the bottom one is equal to v. And then again, you do your differentiation. But now here's where it goes different. Before we started off with u dv times dx, so we went this way and this way. But now what we're going to do, we're going to flip it, right? We're going to go this one first and then this one, and we're going to do minus instead, okay? So we're going to get e to the x times 5. So what I did there, so I did the inverse. So I did this and this times together, and we say minus this times this together. So 5x e to the x, and we're going to divide it by v squared. So e to the x, we're going to divide it by this squared. So e to the x all squared, and that is my final answer, okay? And you could use the product rule and it will give you the same answer. Let's go for another question, okay? Let's go with 5x all over cos 2x. Okay, so I'll give you guys a minute to try that. Okay, given that you tried it, say u equals 5x, v is equal to cos 2x. Differentiate u, du by dx is going to equal 5. dv by dx is going to equal minus 2 sine 2x. And the way I remember how to differentiate sine, cos, and all that, I use this rule. So when you differentiate, you go down. When you integrate, you go up. Okay, so di. So sine differentiates to cos, cos differentiate minus sine to minus cos, SC, and it repeats. Integration is the other way around. So you could just remember that. So I'm going to use the same example. So I'm going to do this times this. So 5 cos 2x minus this times this. So minus 5x times minus 2 sine 2x all over v squared. So cos 2x squared. Okay, and that's the same thing as saying 5 cos 2x plus 10x sine 2x all over cos 2x squared. And that is the final answer. So hopefully you guys have learned something new today about the product and quotient rule, and in the following videos I might do more examples and more complicated examples.